Section 3.6 is a short little section, but it is very useful in that sometimes we will have a product of trigonometric functions and we need to change them into sums or vice versa, and that's exactly what this section deals with. There are actually 7 new identities that you need to learn, but it's a whole lot easier than trying any other method because the other methods would just require way too much time. And so we begin with example number 1, and this first group says express the product as a sum containing only sines and cosines. So that is relatively simple once you use the formulas. Sine of 6 theta times cosine of 4 theta. And we're trying to change this into a sum. So we use the product to sum formula, which says we're going to take 1/2 of the sine of the 2 angles added together plus the sine of the 2 angles subtracted from each other. So that equals 1/2 times the sine of 10 theta plus the sine of 2 theta. And what we have done is we have changed this product into a sum. Number 2, we're asked what's the sine of 4 theta times cosine of 5 theta. And this is identical to the previous problem, just changing the numbers. So all we have to do is change the numbers. So it's going to be 1/2 the sine of the 2 angles added together plus the sine of the 2 angles subtracted. And it is important to make sure that it is in that appropriate order. And so we get 1/2 times the sine of 9 theta plus the sine of negative theta. Now we do have a slight problem. We never want to see negative as part of a sine or a cosine or anything like that. So we do need to use the even-odd identity, which basically says this negative can come out front. And so it becomes 1/2 times the sine of 9 theta minus the sine of theta. Example 3, which finishes up this group. -2 sine of 5 theta sine of theta. Now this is different than the 2 previous problems, and if we look at the identity, the very first identity actually, because we have the sine of 2 different angles being added together, that it becomes 1/2, but we have to multiply by the -2 here. So it's -2 times the 1/2 of the cosine of their difference minus the cosine of their sum. So -2 times 1/2 is negative. So it'll be negative the cosine of 4 theta, just taking 5 theta minus theta, minus the cosine of, well, 5 theta plus theta is 6 theta. And so that is the final answer there. 4, 5, and 6, we need to express the sum or difference as a product of sines or cosines. And this deals with the last 4 identities in this particular section, those that can be found on page 223. And what we have is the sine of 8 theta plus the sine of 4 theta is equal to what? Well, this one, we have the sine of one angle plus the sine of the a second, is the first one in that box. And so that just simply means take 2 times the sine of the 2 angles added, all over 2, times the cosine of the 2 angles being subtracted, all over 2. And then it's just a matter of simplifying this. 2 sine of 12 theta over 2, cosine of 4 theta over 2, which is equal to 2 times the sine of 6 theta, cosine of 2 theta. And there is the final answer. Example number 5. The sine of 7 theta minus the sine of 3 theta. Well, we look for the sine of one angle minus the sine of the other. That is the second one in that list. And so that's the one we will use, which is 2 sine of the 2 angles subtracted over 2 times the cosine of the 2 angles added over 2, which equals 2 times sine of 4 theta over 2, cosine of 10 theta over 2, which will equal, as our final answer, 2 the sine of 2 theta, cosine of 5 theta. Example number 6. The sine of 6 theta minus the sine of 4 theta. And you will realize example number 6 is almost identical to number 5. 2 sine, take the 2 angles and subtract them, over 2, cosine, take the 2 angles and add them, which equals 2 the sine of 2 theta over 2, cosine of 10 theta over 2, which as a final answer will be 2 sine of theta, cosine of 5 theta. Realize it takes considerably more time on these problems to write them down than it does to actually think them through. It takes longer to write them than it does to think them. The final group of problems here asks us to establish the identity. And so, here we go. We have the sine of 7 theta, this is example number 7, plus the sine of 3 theta, all over 2 sine of 5 theta equals the cosine of 2 theta. Now, as we've been moving along, normally you take the more complex side and go from there. What we're going to do is try that, and if it doesn't work, realize we might have wanted to start with the more simple side. But here we have sine of 7 theta plus sine of 3 theta, which is one of the identities. We're taking the sine and adding them together. And so that is, we can use that, and that will be 2 sine of, okay, here's where I'm going to do, well, no, I'll actually show it here, 7 theta plus 3 theta, all over 2, cosine of 7 theta minus 3 theta, all over 2, all over 2 sine of 5 theta. So this becomes 2 sine of 10 theta over 2, cosine of 4 theta over 2, all over 2 sine of 5 theta. This is 2 sine of 5 theta cosine of 2 theta all over 2 sine of 5 theta. Finally, I can do some simplifying. Sine of 5 theta and sine of 5 theta will cancel with each other, leaving cosine of 2 theta, which is exactly what we wanted it to equal, and so we are finished. Very quickly, since I only have one more problem that I want to go over, I'm going to eliminate example number 9. So I'm just going to finish here rather than create a whole nother video. Number 8. The sine of 7 theta plus the sine of 3 theta all over the sine of 7 theta minus the sine of 3 theta is equal to the negative tangent of 5 theta over tangent of 2 theta. Okay, just use the identities a couple of different times, a couple different identities, and then we can go from there. So the sine plus the sine will be 2 sine, and add the angles. 7 theta plus 3 theta over 2. Whoops, not plus. It's immediately times cosine of the angles being subtracted all over the sine minus sine is 2 times the sine of the angles being subtracted cosine of the angles being added. So this equals 2 sine of 10 theta over 2 cosine of 4 theta over 2 all over 2 sine of 4 theta over 2 cosine of 10 theta over 2, which equals 2 sine of 5 theta cosine of 2 theta over 2 sine of 2 theta cosine of 5 theta. Now the 2's will cancel each other out, so we can get rid of those. So we're left with, and I'm going to rewrite this a little bit differently. I'm going to take the sine of 5 theta over cosine of 5 theta times the cosine of 2 theta over sine of 2 theta. Well, sine of 5 theta over cosine of 5 theta is the tangent of 5 theta. Cosine of 2 theta over sine of 2 theta is the cotangent of 2 theta. Well, this is very close to what we want, except instead of cotangent of 2 theta, we want the tangent of 2 theta to be in the denominator, which is pretty simple to get. Tangent of 5 theta times 1 over the tangent of 2 theta, which is equal to tangent 5 theta over tangent of 2 theta.